What straight gaps.
Miss Osborne, you ready for that grade 1 tomorrow?
Yeah, sure.
That sounds very hyped about it.
Sorry, can you repeat that?
So you don't sound very hyped about the grade 1?
Oh. Oh, I guess I'm not.
All right, so I hope the other persons would have looked at our previous video. The one with the revision for, yeah, sorry, I was distracted there. The revision for biology is a very good revision that could also be very helpful for our HSB session as well, right? So I hope you can get a chance to see that. We'll begin in a bit. We're giving you a chance to share the link and for you your colleagues to join us. Persons are saying they're not getting to join. I'm not sure why. All right, so share the link. Give your colleagues, your friends a chance to pass the exam. Some of what we speak about tonight will be on the exam. If you're lucky, most of it will be on the exam. A few persons. Hello to the persons joining us on YouTube. Welcome. For the persons who might be looking at this for the first time, we had a biology crash course a few days ago. You can go and look back at that live video for that biology crash course. Together with what will be said in this video tonight, it should be a good comprehensive revision for everything that's possibly going to be on the exam. All right, so make sure you review that as well. So some of the topics I want to touch on tonight, I'm going to write it here so we can have a tracker of it. We want to look at cells. We want to look at photosynthesis, respiration. Oh my goodness. Who's writing on the screen, man? Can you stop writing on the screen? Right, so we want to look at cells, photosynthesis, respiration, diseases. We want to talk about cancer, diabetes, hypertension, and maybe atherosclerosis. I want to talk about those. We want to talk about gastroenteritis is probably one of the big ones that we can test. Look at sickle cell because that one is new in the syllabus. They can bring a few questions on that. We will look at genetics. We will compare mitosis and meiosis. That's also new in the HSB syllabus, so we can bring something about that. I think something on drugs can come. We want to look at food chains and food webs. Heart, the heart can come. The heart, blood, that can come as well. What am I missing? I made some notes as to some topics I want to review. So I'm going to review that and see what else I want to include here. But that's generally outline, maybe plus a few more. That's generally outline of what we want to look at tonight. We're going to give the others 5 minutes to join us, and then we will start. Remember to share the link with your colleagues, like the YouTube video so the notification is pushed out, and we will begin momentarily. Person just joining us, we are revising human and social biology tonight. This would go nicely with a previous video we had to revise for biology. So the persons who are joining us for the first time, when this is done, be sure to catch that live video on biology revision. The syllabus intertwined. The parts where are for biology alone, I would have said that in the live video. So it will be a very good addition to what we discuss here tonight. Some of the topics that we revise on that live, we will not do it here again tonight. And that's simply because I want to cover as much as we can cover in the event that something outside of the obvious comes. We will start in another 2-3 minutes. All right, welcome again to the persons who join us. Turn your camera off, please, with persons who have it on. We are revising tonight for human and social biology exam. I have put a few topics there that I want to cover. I'll say one more time, this video would go nicely with the topics that we have revised on the biology crash course video. So when this is done, you can go to my YouTube channel and look for that last live video. And that will be a good revision session of the entire syllabus for human and social biology. So check that out. to comprehensively prepare for the exam tomorrow. All right, so we are going to start now. And pay attention because there might be some things that we talk about that will be on the exam. And because you didn't think it would have been on the exam, you weren't paying much of attention. And as a result, you are not able to answer the question when it comes tomorrow. So pay attention. Try to pay attention to as much as you possibly can. All right, so let's start. We're going to start with cells. So we know, or we should know about plant and animal cells. Now, the plant cell is, the plant cell will look something like this in your exam, or they might ask you to draw it, and what you're going to draw is a fixed structure. When I say a fixed structure, this can be the plant cell, so as this can be the plant cell. This is fixed. You can see a regular shape or a pattern there, compared to an animal cell that you will see an irregular shape. All right, don't want to draw a circle because that's not how it really is in actuality. All right, but to get the idea that this fixed part on the left is our plant cell, animal cell on the right. So why would the plant cell be fixed compared to the animal cell? Anybody want to chime in here and tell me? Why is the animal cell irregular versus the plant cell that is fixed? Anybody?
Sure, because the plant cell have cell wall and the animal cell do not have one.
I say you're not hearing clearly on the live. I'm not sure why. Right, so the plant cell has a cell wall and the animal cell lacks one, right? So because of that cell wall, and what's the cell wall made of? Anybody remembers? The persons who are writing on the screen, kindly desist from doing it. Can anybody remember what the cell wall is made of in the plant? It's made of cellulose. Cellulose is a very rigid structure. So you can see cellulose cell wall, you can see fiber cell wall, whichever one you choose, same thing, right? So the cellulose cell wall is a structure that protects the cell, really, and it gives that shape of that cell, right? So plant cell has that cell wall, the animal cell lacks it. The inner side of both would be a cell membrane, so your cell membrane on the outside of the animal cell. And let me just look for a picture rather than go through all of this. Somebody please take a list of these, take a picture of these topics. So if we lose it, you know what to tell me next. I'm going to explain this better. Good, nice one here. This one as well. Persons are looking at me on the YouTube channel. Are you hearing clearly? What he said they weren't. I'm just checking. Let me know in the comments. So you see that rigid structure we were talking about, that regular structure, regular on the left versus the animal cell on the right. Now, we're not going to go through all of these. And when you're drawing tomorrow, please don't use these arrowheads. If this comes, don't use the arrowheads, right? We're going to go through the main structures, and we want to make sure you know the function of the main structures, because they can ask you that in the exam, right? So let's go through it. Let's start with the similarities. What do they have in common? Can anybody tell me what they have in common? Rather than me talking all the time, let's try to have you take part. What these cells have in common? Each of you can tell me one.
Cell membrane.
Yes, we'll start with the cell membrane. They all have a cell membrane in common. Good. Next.
Cytoplasm.
Nucleus.
Cytoplasm, nucleus. Good. Yeah. What else?
Mitochondria.
Ribosome.
Mitochondria.
Nucleus.
Somebody said nucleus already.
Ribosomes.
Ribosomes. Yep. Good. So that's about it, right? Good. So let's start with the cell. Let's start with the definition of these organelles. So you might see a big word like organelle in the exam. Don't panic. Organelle simply means the structure on the inside of these cells. So those things that you basically just call are organelles, right? So don't get nervous when you hear a word like organelle. All right, so the organelles are those structures on the inside of the cell. So we mentioned that both of these cells have a cell membrane. What do you think the cell membrane does? So the cell membrane forms as a barrier, or acts as a barrier, and generally allows for substances to enter and exit, so allow for substances to move in and out of the cell, right? Because the plant cell has that cell wall together with that cell membrane, it does a better job at protecting, right? Or limits what enters and what exits, right? So the plant cell does a better job at limiting what exits, what enters. The animal cell, on the other hand, lacks that cell wall. It only has the cell membrane around it. All right, so while it allows substances to enter and exit, it cannot tightly regulate that. Can you tell me, what process would allow substances to move across the cell membrane? What process would allow substances to move across the cell membrane? It's a good question. So it's a question that can likely to be on the exam tomorrow. It would not come like that, but you should know that you should be able to detect when it comes. So osmosis, right? Osmosis. What's osmosis?
Osmosis moves movement of water molecules from a high concentration to a movement of low concentration through a peripheral membrane.
Right. So osmosis is movement of water molecules. So water molecules are moving across that cell membrane. The cell membrane is acting as a semi-permeable membrane, right? So water and substances can enter, or substances dissolve in water, enter that cell through osmosis, right? Good. And that's for both animals and plant cells. Good. Thank you. So let's go back to talking about the organelles. So what's the nucleus? The function of the nucleus generally is that control center. The nucleus is that control center of the cell. So all the activities of the cell must get that control from the nucleus to carry out those activities. So the nucleus is like the brain of the cell. Please don't write it in the exam. So that's me explaining for you to understand. The nucleus is like the brain of the cell. So all the activities that happen in the cell gets its control or gets its information from the nucleus, right? And then the mitochondria. What do we say that mitochondria is? Students probably remember this alone in high school science. What is the mitochondria?
The powerhouse.
Just the powerhouse. That's all you write in the exam. Mitochondria powerhouse. That's what you write.
You come to stress me out now with
No, I don't want to stress you out. I'm sorry. I hope you don't stress yourself out in the exam tomorrow.
No, sir, not you. Nice, sir.
It's okay. Right. So the mitochondria is the powerhouse of the cell. In other words, that's the site where respiration is going to take place. That is where energy is liberated from glucose and food and all of that, right? So what we write in the exam, mitochondria, the powerhouse of the cell. This is the site where respiration takes place. And let's talk a little bit about this. So if you have a cell or you have a part of an organism that has a lot of mitochondria, what do you think that part of that organism will be responsible for? The part of the organism has lots of mitochondria. What do you think that part will be responsible for? I just told you, the mitochondria allows for what?
Respiration.
Respiration, releasing energy, yeah, but what would it, okay, let me rephrase the question. Which part of the body might have a lot of mitochondria? Which cell of the body would have a lot of mitochondria?
Sorry, the muscle cell?
The muscle cell. And why do you think the muscle cells would have a lot of mitochondria?
Aerobic respiration.
Because the cells of the muscle will be using a lot of energy to do activities, right? So they need to have lots of energy. And for them to have lots of energy, they must have lots of mitochondria. Be careful not to just write a one-word answer when they're asking you to explain something, right? You have to try to be clear, especially for those questions that ask you to explain. If a question asks you to identify a list, you can just put a word there, that's fine. But explain or describe, you want to put something more. Right, so the mitochondria is a powerhouse of the cell, is a site where respiration takes place. So if you have mitochondria present in the muscle cells, it means the muscle cells will need a lot of. Hold on for me, please. You good? Yeah, man. Yeah, what was I saying? The muscle cells would have lots of mitochondria simply because the muscle cells require a lot of energy. Good. Where are we next? Nucleus, mitochondria, cytoplasm. What's a cytoplasm? What's a cytoplasm? The cytoplasm is a jelly-like substance. A jelly-like substance that holds all the activities or that provides a reservoir for these organelles to be, right? Hold on, just send this message. Yeah, so cytoplasm is that jelly-like substance that holds the organelles. The ribosome, what the ribosome does. Come on, guys. Ribosomes do what?
Produces protein.
Produce the protein. Produce the protein. Good. What are we missing here? What else is important I want to talk about? Oh, so let's talk about the differences now. So our plant cell has a cell wall. We spoke about that already. And the plant cell also has a structure called the chloroplast. And what do you think the chloroplast is responsible for?
Photosynthesis.
Yeah, photosynthesis. So it allows for the trapping of sunlight. And when that sunlight is trapped, it allows for that chemical energy, for that light energy to be converted to chemical energy, and for that chemical energy to go on to make food, right? So chloroplast traps sunlight and allows for photosynthesis to take place. Good. Anything else you want to talk about? look at this this large structure in the middle here. What's a large structure in the middle there called? The animal cells have small ones, but the plant cell has a very large one at the center. What do we call that?
The vacuole.
Not just vacuole, I want to hear something else.
The large permanent vacuum.
Very good. Large permanent vacuole. Large permanent vacuole. Now, a vacuole is a reservoir for storage of water and minerals, right? So the reservoir for storage of water and minerals would be that large permanent vacuole. So let's do one application question of this. If they bring it as a simplified question and just ask you to label a few parts or for you to define some organelles, that would be good for you. But let's just try to apply this knowledge here. If they bring cells, they oftentimes will bring cells mixed with another topic, for example, osmosis and diffusion, right? So let's try to tie in osmosis and diffusion with the same topic here. So let's say we have Farmer Brown. So Farmer Brown has some lettuce or some shallot or some dark leafy vegetables on his stall at the market. And during a hot day, Farmer Brown realized that this celery, this green leafy vegetable, wilts very quickly and easily. Why do you think that's so? What is happening? What's happening to that leafy vegetable that's causing it to look wilted or dried up? Give me the term for the science. Anybody? Green leaf. Wilting, transpiration, loss of water through the leaf, right? So that's something that you should know. The transpiration occurs because of the heat and all of that, so water is lost through the leaf. So the plant looks dry. Good. After some time, Farmer Brown sprays or throws some water on this dark leafy vegetable, this lettuce. And after a few minutes, this looks fresh again. Why? Explain to me why. Quick takers? Why would it look fresh again? Nobody? I'm disappointed. So osmosis has happened. Osmosis has occurred. So water molecules are moving from the outside, wherever it's thrown from, to the inside of the cell. So the cells will take in water by osmosis, right? And as this is a plant cell, that water will be stored in your vacuole, right? That vacuole will take in as much as it can. That vacuole will stretch, then press against that cell membrane, which press against the cell wall, and this plant will start to look nice and fresh again. Anybody can tell me the word that describes that fresh look? Turgidity. Turgidity, right? That's simply a term used to describe the gaining of water by osmosis, the cell looking nice and plump, right? Good. So let's move on from osmosis and diffusion together with cells. Our next topic on our list was what? We still have this. Let me see. The previous one. Anybody took a note of our topics that we were supposed to schedule to do? What was the next one? Trying to find our previous board. Anyway, not finding it.
Photosynthesis, sir.
If nobody, I'm just warning you. If nobody talks, this call will end very quickly, right? That's the last thing I'm going to do. I'm not going to be talking to myself, right? I'm quite sure the person's on YouTube. In fact, let me give the link, because if you people don't want to take part in the session, the persons who are on YouTube are going to be very much grateful for this session. So let me send that to them. Because if I'm going to be the only one talking to myself, it's best I go sleep. I've been talking all year, so you should have been paying attention in classes. But this last minute thing, if you didn't catch it 1 year ago, you wouldn't catch it the night before the exam. Anyway, moving on. Next topic is supposed to be photosynthesis. So the exam can ask you whatever tricky way they have it to show why photosynthesis is important, or simply ask you to define photosynthesis. What exactly is photosynthesis? So photosynthesis is that process that green plants that are green because they have lots of chloroplasts and they're making their own food. How are they making their own food? Let's look at that equation to summarize that. We're going to start with the word equation. So water plus carbon dioxide glucose and oxygen. All right, so that's the process of photosynthesis. That's a word equation. So as you can see, the word equation is using words, and our chemical equation will use chemical symbols, right? So 6H2O plus 6CO2. That's supposed to be a 2. Glucose, C6H12O6. Kindly desist from writing on the screen. Plus oxygen, 6O2. This is a balanced equation. The balanced equation means the components on the right-hand side equal to the components on the left-hand side. So that's why you're putting these numbers in front to balance it out. If you're not doing chemistry and you really don't care about balancing the equation much, just cram the equation and you're good to go there. If the question asks you to describe photosynthesis for a 3, 4, 5 marks, you want to do a little bit more than just saying green plants making food. So you want to tell me where the water is coming from, where is the carbon dioxide coming from, what is happening to the glucose, what is happening to the oxygen. Again, if the question is a 4, 5 mark question to describe photosynthesis, you want to say where is the water coming from. Water is coming from the root by osmosis, traveling up the stem to the leaf. Carbon dioxide is coming into the leaf through the stomata. Glucose is produced and then is translocated to the storage organ. And then oxygen is released as a byproduct of the process. Does that make sense?
Yes, sir. Yes, sir.
Okay. All right, next on my list is diffusion, is diseases. So we will define disease, we will define health, and take it from there. So what is health? Health is the complete physical, complete physical, social, mental well-being of an individual. So all of these parameters must be okay for you to say you're healthy. So if you're to factor in all of these things that must be present, then really and truly many of us are not very healthy, right? Because we can't form a conversation with somebody, things like that. So the social problems can affect your health as well. So the exam can actually define health. Health is the state of complete well-being. That is, their physical health, their social health, and their mental health must be well for that person to be characterized as healthy. And what's a disease? Anybody can tell me what a disease is? Simply put, a disease is any condition that affects health. Simply put, the disease is any condition that affects somebody's health and well-being. All right, so some diseases, we are going to categorize diseases now. So to categorize this, we're putting them in categories. So let's say our communicable, sorry, my penmanship is so bad, and non-communicable diseases are two major categories. That's wrong. So these are called NCDs, CDs. So your communicable diseases and your non-communicable diseases. So let's talk a little bit about those. Communicable disease are those that spread from person to person. Disease spread from person to person. Non-communicable disease do not spread. So these are not something that you can catch. These are not infectious, right? But these are caused by environmental conditions, lifestyle choices, and nutritional factors or the environment, lifestyle, environment, genetics, and time genetics there as well. So your non-communicable diseases are diseases that don't spread from person to person, but they are as a result of lifestyle, the environment, genetics, right? Good. Let's do some examples of them now. Examples of your communicable: gastroenteritis. HSB exam likes to bring this one. What's another name for gastroenteritis? What do we know that as?
Food poison.
That's food poisoning. And the Guyanese call that shitting. So. Right, so vomiting and diarrhea, those are your chief signs and symptoms of gastroenteritis. Your non-communicable disease, main ones that you should know: diabetes, cancer. What else? Hypertension. Atherosclerosis.
Sickle cell, sir.
Yes, sickle cell would fall under this. On the communicable, you have malaria, anything that can spread. COVID.
HIV.
All of your STIs, HIV, syphilis, gonorrhea, trichomonas, candidiasis, all of your STIs or STI. Just stick this in here because they like to ask about this. Opportunistic infections. We'll talk about that in a bit. All of your STIs, right? And good. So let's recap that. Somebody tell me what's a communicable disease. Somebody tell me what's a non-communicable disease.
Sir, a communicable disease is a disease that is spread from person to person.
Example,
Your STIs, malaria, or COVID.
good. And non-communicable disease, somebody else tell me what that is.
Cancer and diabetes.
But what is it? You can't write examples as a definition. If the exam asks you to define it, you can't write that. What do you write?
They do not spread from person to person?
Non-communicable disease don't spread from person to person, but how are they cause them? So you can't just tell me that alone. They are not caused by spreading from person to person, but they are caused by what?
They're caused by environmental lifestyle, like
Environmental conditions, lifestyle choices. Don't make it sound as though it's the same word, right? Environmental conditions, lifestyle choices. What else? Genetic
Yeah.
factors, right? Good. All right, good. So let's talk. We will choose to talk about diabetes, cancer, atherosclerosis. We will talk about these three. We will talk about gastroenteritis and malaria. Right? Hopefully, if they bring me tomorrow, one of those that we talk about there will be on the exam. Good. Quickly talk about diabetes. What's diabetes? Diabetes is a condition or a disease that is characterized by high blood glucose level. High blood glucose level. So there's a high blood sugar level. Why is there a high blood sugar level? Because of insulin being absent or not working. So again, what's the cause? What's diabetes? High blood sugar. Why is that so? It's either insulin is not present at all or insulin is not working. And there are two types of diabetes. What are those?
Type 1 and type 2.
Type 1 and type 2. There are others. You will hear about gestational diabetes. You will hear about insipidus. There's so many others, right? But you're concerned with type 1 and type 2. Type 1 diabetes is what we used to call, we don't call it so anymore, we used to say diabetes of the young, right? But now it's not only the young people who have it. And type 2 diabetes used to be the adult diabetes, but that's not the case anymore. The presentation is differently, and you will tell me, and you will see why. So in type 1 diabetes, the beta cells of the pancreas, so the pancreas is this beautiful organ that produce lots of hormones and lots of enzymes as well, right? And in that pancreas, there is something called beta cells, and the beta cells produce insulin. When the beta cells are destroyed, what do you think will happen? No insulin, right? So in type 1 diabetes, the beta cells are destroyed, which lead to no insulin. What insulin does is lower the blood glucose level. So in type 1 diabetes, if there's no insulin, then there is a high blood glucose level because there's nothing there to lower the blood glucose level. Make sense?
Yes, sir.
In type 2 diabetes, the problem is not initially insulin. The problem initially at the start is fat. So fat or adipose tissue. Fat cells prevent insulin from working. So fat cells prevent working. What does that mean? It means that insulin cannot do what it's supposed to do in the presence of extensive amount of fat. So in type 2 diabetes, are you seeing this blue structure on the screen?
No, sir.
No, sir.
Right. So in type 2 diabetes, the person is usually obese. Right? And that excessive amount of fat that they have prevent insulin from working well. You would see this in your books as insulin resistance. Insulin resistance. What does that mean? The insulin is not working well because of all of that fat. If the insulin is not working well, what do you think that would cause? The body doesn't know is the fat the problem. The body thinks the problem is not the fat, but is something else. So tell me, what would the body do?
Make more insulin.
Right, the body will make more insulin. And it makes more and more and more and more until those pancreas cells are burnt out. So they can't produce anymore. They're tired, right? So eventually it will lead to high blood glucose level because the insulin is no longer what they used to be. It's not being produced as they used to be produced, right? So what starts off with insulin resistance would lead to a lack of insulin, right? And lead to the same thing, high blood glucose level in the blood. Can anybody remind me what insulin functions to do? Why is this insulin so important? Why is the insulin so important we're talking about all the time?
To break down glucose?
Yeah, to lower the blood glucose level. And how can you tell me the two ways that insulin lowers the blood glucose level? I usually talk about this in my physical classes. Can anybody remember the two ways that insulin works to lower your blood glucose level? No? So insulin generally opens the cells of the body, and the cells of the body takes in glucose. There's a fancy mechanism for that. When you do advanced science, you will learn about that. But for now, all you need to know, insulin opens the cell, and the cell takes in glucose. What's that process called? When dissolved substances enter the body cells, what process we call that?
Assimilation.
Very good. That's assimilation. Very good. And now, what's the other way that insulin works?
Sir, it causes the glucogen to be broken down into, I think, glucagon to be stored around the
You're all over the place.
liver.
Stop talking. You remember hearing it in class, but you can't remember exactly what was said. So if you're using different words to put it together, hopefully you get the answer. All right, so simply put, insulin allows for glucose to be stored as glycogen in the liver, right? And how long is that glycogen stored for? I tell my students all the time. So anybody, how long? Period of time. A day, a week, a month, a year. 24 hours. 24 hours. Good. So again, the two ways insulin work. One, allows for glucose to be taken into the cells of the body. And two, give me a minute. And two, it allows for the cells of the liver to store that extra glucose as glycogen. Please don't confuse glycogen and glucagon. Anybody remembers what glucagon is? Anybody remembers what glucagon is?
A hormone?
It's a hormone, yes. So insulin lowers the blood glucose level, and glucagon raises that glucose level. So if somebody is starving, the body releases glucagon. And what do you think glucagon will do to raise that glucose level? I just told you that insulin will cause glucose to be stored as glycogen. So when the person is hungry, what do you think glucagon would do now? And by the way, glucagon comes from the alpha cells of the pancreas. So the beta cells produce insulin, and the alpha cells produce glucagon. What will glucagon cause?
Glucagon cause the glycogen to turn back to glucose.
Very good. Glucagon will make the glycogen free up as glucose molecules. So you're creating new glucose from what was stored, right? So that's what glucagon does. It's the reverse of the insulin, right? So that is diabetes in a nutshell. Remember, diabetes is characterized by high blood glucose level. It's caused because the body either lacks insulin or the insulin is not working well. There are two main types, type 1 and type 2. In type 1, there's a destruction of the beta cells. That beta cell, when they're destroyed, leads to insulin not being produced. If insulin is not being produced, then insulin can lower the blood glucose level, and that's why you have a high blood glucose. In type 2, it's not about insulin, the beta cells being destroyed, but it's about fat causing insulin to not work properly. So the body produces more and more and more and more insulin until it burns out, and then when it can produce more insulin, the blood glucose level remain high. Let's talk about some signs and symptoms of diabetes, because the question can give you a few signs and symptoms and you have to figure out what a person has. So, signs and symptoms of diabetes. What does a person with diabetes, what would a person with diabetes observe? Tell me the three main ones first, and then you throw in the things that you're not sure about. What are the three main signs of what we call the cardinal signs of diabetes? Cardinal signs of diabetes.
Frequent urination, hunger, and I can't remember the other one.
They get like stuff on their skin, I believe, like blue-black patches.
Excessive thirst.
Do I have any science students in the class that wants to give me a science answer?
Polyuria, polyphagia.
And polydipsia.
Thank you. Polydipsia, polyphagia, polyuria. Polydipsia, polyphagia, and polyuria. Good. Those are your main signs and symptoms of diabetes. Polyuria means frequent urination. Polyphagia means frequent hunger. Polydipsia means frequent thirst. So those are the three main signs and symptoms of diabetes. Now, once you put the main ones, and if they say they want some more, you will throw in some other things. What are some other things of diabetes? Don't tell me some things on the skin. That's not acceptable as a science student, right? So you want to say things like frequent infections, and particularly frequent urinary tract infections, frequent UTIs. Why are they having frequent UTIs? Because they have so much sugar the body is trying to get rid of it through the urinary system, and that is a reservoir for bacteria to grow, right? So frequent urinary tract infection. Headache. Yeah, all that sugar can cause some headache, but a very good one is weight loss. Weight loss. After weight loss, another very good one is non-healing ulcers or sores or wounds. So those are you can add these to the other three main signs, and you can call those your signs and symptoms of diabetes. Anybody can tell me why the person might be losing weight? Why does a person with diabetes lose weight? If they want to hot up here, they can ask you that in the exam. Remember, the problem with diabetes is that the cells of the body is not getting glucose. There's lots of sugar. There's lots of sugar in the blood, but the sugar doesn't have to be in the blood. The sugar has to get to the cells of the body. So if the body's cells don't get the sugar, the body is thinking that there is not enough sugar. So what would the body do? Break down fat in an attempt to liberate sugar, right? To get more sugar, the body is breaking down fat. So the person is losing weight because the body is thinking this person is hungry, and they're trying to break down this fat to free up this glucose. Does that make sense?
Yes, sir.
Let's talk about the complications now of diabetes, and this is something everybody should know. It's not just about exam purposes, but diabetes is the number one non-communicable disease in this part of the world. In fact, the world, but it's killing a lot of people of color. So you have to know it. You really, really have to know it. So let's talk a little bit about that. Can the persons who are trying to control the screen stop doing that, please? Good. So let's talk about the complications. So the thing about the complications of diabetes, the high blood glucose level affect every organ of the body. That high glucose level affect every organ of the body. So that can tell you what you can have. Every organ can be affected. That high glucose level can cause blindness. The person can go blind, right? That's affecting the retina. It's causing a small bleeds on the retina, leading to blindness, right? It causes kidney failure, or what we call nephropathy, right? Kidney failure, heart attack. This is the number one way of persons with diabetes die. Persons with diabetes, the way they often die is by heart attack. The next thing is stroke, right? It can cause stroke. It can cause amputation. Amputation. Can any one of my science students tell me why persons with diabetes oftentimes get their foot cut off? Why?
Because abscess is present.
What's that?
Because the
nerve
cells die.
damage.
Necrosis, I believe.
No.
Sir, because they lose this sense of touch, they can get a sore, or they could get a sore, and if it accumulates for too long, it could be like lead to nephropathy. My God, I'm saying wrong terms. Sir, basically, they can have a sore, and because they don't have the sense of touch, or they could have caused something to cause a sore, and they wouldn't know they have it. And after a while, it could lead to an infection, and after a while, they will probably have to amputate it.
All right. Not just anybody else?
Damaged nerves in the foot. So the damaged nerves, they cannot have the proper nourishment and food supply that's supposed to go to them. So that part of the body become dead at times.
So, okay. Anybody else?
Because of less blood flow. Because of reduced blood flow can cause that too.
All right, let me just give you. Thank you. So it starts with two things. One, I told you high blood glucose level affects every organ of the body, every structure in the body. One, it affects nerves, right? That's called neuropathy, right? Neuropathy. So it affects nerves, the nerves are killed. The nerves die. If the nerves die, what are nerves supposed to do? Give you a sense of touch, give you a sense of feeling, right? So somebody can be stuck with a needle, stuck with a nail, and they don't even know. Grazed by a nail, they don't even know. So they have their foot with this open wound. That open wound can cause infection or can be infected. When the open wound is infected, that infection spreads quickly up the leg, right? Oftentimes, to curtail or to stop that infection from spreading, you have to amputate the leg. If they don't amputate, it can lead to sepsis. That sepsis is where the entire body becomes overwhelmed by that infection. That sepsis is that infection in that blood. Usually the blood is sterile, so anything that is infectious in blood can be dangerous, right? But do you have an understanding of what I'm saying there?
Yes, sir.
Yes.
So the amputation is the body's mechanism of not the body's mechanism. Dehabitation is our mechanism from stopping that overwhelming infection. Right? So you had bits and pieces of it, but you have to put all of it together. Good. Those are your complications. Let's talk prevention and treatment. Prevention and treatment. So prevention, this is the same prevention you will talk about for all non-communicable disease, right? So nothing big and fancy. Just know it for all of them. Good. Now, think about it. Give me a minute. Think about prevention of non-communicable diseases.
A healthy lifestyle.
Exercise.
A healthy diet.
Good. I'm hearing bits and pieces of it. Good. Lovely. So diet. The diet. Hey, I'm doing something. You see this diet? This thing about diet? This is gonna fix all our problems. All the disease the world has, many of them can be fixed by fixing our diet. You see, us Caribbean people, we like eat. Imagine if you go and buy a food at a corner shop, right? And the people give you half of the box is vegetables, and a little piece is some rice, and a piece of chicken, but lots of vegetables. How are you gonna feel?
I get robbed.
You feel you get robbed. You feel, it's like, what's going on? They ain't paying for grass. We expect a lot of rice or a lot of flour-based product, and that's what's killing us. Diabetes is not caused by eating sugar, Diabetes is caused by eating carbohydrates. Carbohydrates include your ground provision, your rice, your flour-based products. That's what is breaking down to glucose in the body. So eating so much carbohydrate, too much of that, lead to fat, and that fat lead to the onset of diabetes later on. And you know why, right? So eating a balanced diet. And what is a balanced diet? So that's your first prevention. Balanced diet. Can somebody define a balanced diet for me?
Sir, a balance.
A balanced diet includes food from all the major food groups in correct proportions. What is a protein? A balanced diet includes food from all the major food groups in correct proportions. So how much of what we need is what we get. That's important, right? Regular exercise. Can you tell me what is regular exercise? Five days a week for at least 30 minutes of aerobic activity. So activities that allow you to sweat, right? Get your heart rate up, right? Regular exercise, 30 minutes a day, 5 days a week, right? What else can we do to prevent diabetes? Can you tell me how the exercise work to prevent diabetes per se, based on what we talked about earlier? How does the exercise help?
It burns off the excess sugar.
Okay, anything else? So one, it allows you to lose weight, right? Losing weight, remember we said insulin resistance was the cause. So if you lose weight, you decrease the insulin resistance and you help yourself in that regard. The second way is by allowing the cells of the body to take in more glucose, right? So you lower your blood glucose level that way, right? So those are two major ways that exercise work, right? Regular checkups, getting regular checks by your doctors, right? Good. They will often ask you for two because they expect you to say these two here as major. And this is not just about diabetes, but this is also about height. This is also from hypertension as well, right? So for hypertension specifically, for high blood pressure, hypertension, high blood pressure, you want to decrease salt intake. Salt intake. Decrease the salt intake, and you want to increase fiber intake. Right? That's not just for, this fiber is not just for hypertension, but it also works wonder for diabetes as well. Why fiber? Sometimes you may spell it with a R-E. Why fiber? Because fiber allows for bulking. So you would feel full for longer. And if you feel full for longer, you eat less. If you're eating less, it means you are not going to be consuming a lot of carbohydrates. Right? So you feel full for longer. And where do you get fiber from?
Green vegetables.
Vegetables, not just green vegetables, all vegetables. And your fruits, right? The fruits of the skin of the fruits, the skin of the vegetables, very rich source of fiber. Fiber, also called roughage, also called cellulose, same thing, right? Good. So that's diabetes in a nutshell. Let me look for a picture and talk about atherosclerosis.
What about coffee?
What about coffee?
Speaking about fiber just now, so I'm asking, what about coffee? Coffee doesn't have a soluble fiber in it.
Coffee doesn't have what?
Coffee has a soluble fiber in it. That's why I asked, what about coffee?
I'm not sure what you're talking about.
Like coffee grain.
Okay. I still don't know what you're talking about.
Coffee grain, a form of fiber.
Coffee is not a very good source of anything. Coffee, while you might get a chance to stay up for a little longer, some people more than others, coffee is a drug, contains caffeine, and caffeine raises your blood pressure and get you stressed, which can ultimately lead to hypertension. Not hypertension. Yeah, hypertension too, but diabetes as well. All right, let's start with atherosclerosis, or this plaque buildup. So, from the minute you're born, fat or fats and oils build up in the walls of your blood vessels, particularly your arteries, right? When these plaque build up, fat plaque build up, when they build up, what do you think is going to happen to that nice flow of blood in the lumen of your blood vessel?
It's interrupted.
It slows down.
Slows down, interrupted. Let's talk about the pressure. What happens to the pressure in this blood vessel? Will the pressure increase or decrease? Increase, right? So the pressure increasing, that's dangerous. But most importantly, as this plaque builds up, what can it lead to, obviously?
Myocardial infarction.
Infarction, okay. But I want you to see something before we get to that. What is this going to lead to? If this is continuously building up, what would that lead to? A blockage. A blockage. Good, a blockage. Now let's talk about this blockage now. If this blockage happens in the heart, it's going to be called a myocardial infarction, or an MI, or a heart attack. Simply write heart attack. Don't try a song brains. Heart attack, right? Right? And that's the major way that people go out, especially those persons with diabetes. In fact, mostly if you die of natural causes, more likely it's because of heart attack. So this can also lead to the clotting of blood as well. And if this happens in the brain, it can lead to a stroke, right? So remember we said that this blood vessel has a high pressure, right? If this pressure continues to increase and this pressure is hitting on this wall, what can ultimately happen to the wall of that blood vessel? Increased pressure hitting on that wall. Yeah, it can burst.
Tear it?
Yeah,
Or
it bursts. And if that happens in the brain, what do you think is that?
Aneurysm?
No, the bulging of it will be an aneurysm. The bulging of it will be an aneurysm. But if that tearing happens or that bursting of that blood vessel happens and blood is leaking out, that's a stroke. That's a stroke. So there are two types of stroke. There's a bleeding stroke, and then there's a stroke caused by ischemia, which is that blockage, right? So it can be a bleeding or a hemorrhagic stroke, and an ischemic stroke because of a complete block, right? So both are strokes. Good. So this picture came a year in the exam, and they asked you to identify the disease. Was the disease atherosclerosis? What is some cause of the disease? You should know. Fatty foods, lack of exercise. What else? Two big culprits there. So how can you prevent this? How many persons like eat the skin of the chicken? When you go to KFC or you go to Popeyes or you go to McDonald's, where you enjoy the skin of the chicken. Tastes good, right? Anything that tastes good is bad for you. Anything that tastes good is bad for you. So why you eat when it tastes good? Say, oh my God, this is not good for me at all. Anything that tastes good is bad for your health. So you can imagine the grass. It can't be true?
No. There are many things that can taste good that can still be healthy.
Like what?
Like, I don't know, bread and peanut butter, avocado, a salad.
A salad tastes good.
Yeah, like if you season it right, it'll taste good. People just eat bare salad. And that's why they don't enjoy it.
While we're on the point of seasoning, you see, do you know that hypertension? Do you know that hypertension is more than likely to affect people of color than white people? You want to tell me why?
Because of our diet?
Because we must taste the seasoning. If we don't taste the seasoning, our ancestors are not happy.
Amen. Not all seasoning has salt.
And it's oftentimes the seasoning is very salty. And if you have to put salt in something for the entire pot to taste good, you've added too much salt. What do white people do?
Cook tasteless food?
Sorry, I don't have to cook with salt. They have vegetarian cubes. They have cubes.
Well, sweet girl, cube, get salt. So me know what argument you're making. They say, in fact, the salt content in the cube is more than using the salt. So let's not make that argument, right? Or make it, vegetarian cube. Like if the cube is still not cube. So let's not make that argument at all. The point I'm making, all of these things that we add to the food is increasing the sodium content. The sodium content is bad for us. Why? Because the body will always take in sodium. It will always keep sodium. When it keeps back sodium, it's also keeping back water. When that water is kept back, it raises the blood volume, which raises your blood pressure. So that's why it's bad. So oftentimes, Black people have problems with hypertension. Why? our diet is bad. The white man will cook their tasteless food and then they will sprinkle some salt at the top of the food. It makes sense. Why? If you have to add salt for a whole pot to taste good, you have added too much salt. But if you have to sprinkle some salt at the top of a food that you're eating, which one has less? The whole pot or the top of the food? Top of the food that has less. So less salt, less problems with hypertension. Very, very serious, right? So when you examine hypertension or high blood pressure, the caveat is to stay away from salt. Stay away from salt. That's what they're looking for, right? Stay from salt, increase fiber intake. Good. Second topic done there. Let's quickly talk about cancer now. What is cancer?
The rapid growth of cells. Uncontrolled rapid growth of cells.
Everybody member point. It's not controlled. So cancer is the uncontrolled proliferation of abnormal cells. So what does that mean? So the body has cells, and the cells are going to divide by mitosis. And then there are some cells that don't stop dividing. So those are abnormal cells, right? It's the same cell that becomes abnormal, right? We're not going to go on to talk about how those become abnormal. But the same normal cell becomes abnormal because it can't stop dividing. And then when it can't stop dividing, it continues to proliferate, continues to divide and divide and divide until it's this growing mass that is invading blood vessels or causing the generation of new blood vessels of its own and taking away nutrients from the person's body. So, cancer, uncontrolled growth of abnormal cells or proliferation of abnormal cells. Just like diabetes, it can affect any part of the body. So any part of the body can have cancer, right? So let's talk a little bit about some risk factors. The exam can ask you about risk factors. What are risk factors?
Things that would cause you to have it or get cancer.
All right,
or
good.
increase the likelihood of getting it.
It's not necessarily cause, but I like how you're thinking. Very good. It said increase the likelihood. Excellent. That's exactly what you have to say. It increases the likelihood of getting something. It's not necessarily the cause, but it's not necessarily not causing it. It's just in between. It increases the likelihood of leading to something else. Good. So diabetes, what are some risk factors of diabetes and hypertension? We talked on this before. We touched on it. What would be some risk factors of diabetes and hypertension?
Having a bad diet.
Diet. Comes back to diet. What else?
Hypertension.
Not exercising enough.
Genetics.
Genetics. Very good. What else? Being obese, consuming alcohol, smoking, being black. That's a fact. Race is a major risk factor for developing diabetes and hypertension. Right? What else? Fast food intake, sedentary lifestyle, not getting exercise, eating lots of fast food, What else?
Sorry, age could be what?
Very good. Age. Very good. Aging is another factor. Very good.
Gender,
Now,
sir?
gender. Yes. Female are more likely to have these diseases than men. Why? Because oftentimes females have more body fat. Why? Because females have a hormone called estrogen that is high. Estrogen causes the buildup of fat. So, good. We're going somewhere. Now, let's categorize these risk factors as modifiable and non-modifiable. This is how your exam will come. They will ask you for 2 modifiable characteristics or 2 non-modifiable risk factor. What's a modifiable risk factor? The young man just said a risk factor is something that increases the likelihood of getting something. So what will a modifiable risk factor be now?
Poor diet.
I am not asking for an example. Define for me risk factor that is modifiable.
You can take measures to change them.
Good. So these are things that can be changed or altered. And non-modifiable are things that you
Sir?
Sorry, dear. Yeah, that would have stopped. You hear me? Hello?
Yeah, I can hear you.
Right. What were we talking about?
Risk factors and modifiable and non-modifiable factors.
So I think I was asking you what is a modifiable factors. You said those are the ones that we can change, and then the non-modifiable ones are the ones we can't change. So what are the non-modifiable characteristics that we can change? Age.
Gender.
Sex, gender. Good. You can't change that, right? Your age, your sex. What else you can't change? Genetics. Very good. What else? Race. You can't change that. Good. What else? All right. What can we change now?
Lifestyle.
Lifestyle choices. You can't just say lifestyle. We have to change our lifestyle choices. What we eat, how much we exercise, how much weight we gain. Those are modifiable ones. All right? Good. Very good. You all understand this assignment. Lovely. Let's move on. Let's talk. So what are some cancerous factors now for cancer?
Radiation exposure or being exposed to high amounts of
exposure to radiation.
Smoking, tobacco.
Smoking. Yeah, smoking is a smoke. Why is it so light? What happened here? This. Sorry, hold on. All right, good. What was I saying? So smoking, alcohol consumption, What
Being
else?
exposed to chemicals.
Unhealthy eating.
Yeah, obesity. Obesity. Again, gender. Women are more likely to have cancer than men. And the reason for that is the high amount of estrogen. Right? Estrogen is a major teratogen. It's not teratogen, a major carcinogen. Obesity. Why is obesity leading to cancer as well? Same reason. Obesity, that high fat content, also increases the presence of estrogen. So the two play hand in hand. Right? What else is another risk factor of cancer? Exposure to radiation, we said that. Genetics. Genetics. Your family, your mother having breast cancer increases the likelihood of you having breast cancer. Infections. Anybody can tell me a major infection, STI? An STI infection that lead to cancer?
Human papillomavirus.
Yep, HPV. HPV lead to
cervical cancer.
Yep, cervical cancer. And the thing about this one is that it's completely preventable. How many of you know that there's an HPV vaccine? The HPV vaccine is free and you can get it from your Ministry of Health. And it prevents not only cervical cancer, but several other cancers, penile cancer, anal cancer, so many other cancers it prevents, right? So you want to make sure you get vaccinated, right? Good. I often say that every year I teach this class, and I'm sure many persons don't actually go on to get vaccinated. But you know why people don't get this disease? You know why people don't get cervical cancer? You can tell me why?
Because one, they probably do regular checkups with the doctor.
No, they get vaccinated. That's the reason. They're vaccinated. But I'm telling you that to get this vaccine, and none of you will get this vaccine 1 year from now. Right? That's the reason the attitude is different. HPV is cervical cancer, the disease of the developing world. The developed world don't get it because people are vaccinated against it, right? Yep, so that's your risk factors on cancer. So the exam likes to ask something, signs versus symptoms. What's a sign, what's a symptom?
Symptoms are things you feel.
Sound like somebody.
Sign is something that you can see, where a symptom is something only experienced person.
A sign clinical manifestation of a disease. So what we see. And the symptom is what is felt. So the person has to report to you what they're feeling, right? Good. Gastroenteritis, also called food poisoning. Good. So examples of some signs. What are some signs you will see in case of diseases?
Rash.
Rashes, very good.
Low blood pressure.
A high blood pressure, very good. A temperature as well. You may say, oh, well, you can feel the temperature, but no, you can take a recording with a thermometer. So that can be a sign as well. What else?
Rapid weight loss.
Weight loss, very good. Vomiting, diarrhea, you can see that, right? What else? All right, so those are symptoms now. The person will tell you they're feeling tired, they're feeling weak, they're feeling fatigued. Those are symptoms, right? Next. Oh, so next we're going to do gastroenteritis. So what's gastroenteritis? Food poisoning, that's basically. So this person is getting food poison because let's say they went to the toilet, they didn't wash their hand, and then they touched food, and they fed somebody that food, lick up their fingers, bacteria, viruses that was on the feces end up in somebody's mouth, right? And then they have a whole cascade of vomiting and diarrhea or food poisoning. How do we prevent this?
And hygiene?
Basic
washing
hygiene
off your hands.
and washing, sterilizing, using sanitizers, all of those. Yep, but what else can we do? Think about the food now, the actual food. Oh my God.
Good food hygiene.
Keep hot food hot and cold food cold.
Good. I know when I hear when my students go in the exam, they just hear my voice in their head. Hot food, hot, cold food. These are things that we talk about over and over, right? And you will hear it again when you go in the exam tomorrow. Don't worry. Keeping hot food hot and cold food cold. What does that mean? Foods that are supposed to be warm or eaten warm should be warm. If you eat food that's supposed to be warm, cold, bacteria will grow. If you eat food that's supposed to be cold, warm, bacteria will grow, right? And that will cause the gastroenteritis symptoms. What are some signs and symptoms of gastroenteritis? We know the vomiting and the diarrhea. What else is there?
Fever.
Fever.
Nausea.
Excellent. Fever. Nausea. What's nausea? You want something bright. What's nausea?
Feeling lightheaded.
Nausea is feeling like that. Nausea is a feeling to want to vomit, right? Yeah? You're feeling nauseous. You want to vomit. And then when you actually vomit, it's vomiting. Right? So like being lightheaded, okay, feeling fatigue can be one as well and you will get those after you're dehydrated. So that means you've had lots of bouts of diarrhea and vomiting. So you feel dehydrated afterwards, right? Abdominal pains or abdominal cramping, belly pain, belly cramping. Good. Those are others. What else? Anything else? No? Good. So we said hot food, hot, cold food, cold. Wash hands after using the toilet. What about drinking contaminated water now? So some people who are living in slums or underprivileged areas, they can't control the kind of water that they have access to. How can they treat the water to prevent gastroenteritis?
Boiling.
They can boil the water.
Chlorination.
They can chlorinate the water as well, and both of them work similarly. Chlorine is slightly better than the boiling, but both of them work by killing the pathogen. What's a pathogen?
Disease caused by microorganism.
Disease-causing organism. So your disease-causing organisms will be killed by the chlorination and the boiling, right? So is there anything else you can do to prevent these diseases? Washing hands before or after using the toilet. Washing hands before or after preparing meals. Anything else? Good. Moving on.
Rotavirus vaccination.
Excellent. Excellent. Rotavirus is the major cause of vomiting and diarrhea in children, babies. You don't take rotavirus vaccination as adults. That's something you were vaccinated against as children. Because rotavirus causes very bad diarrhea, particularly in children, rotavirus. When I was a medical student, there was a time where I was very angry at a parent, a young mother. She came to the hospital and she was an anti-vaxxer. Oh, I don't believe in vaccination, blah, blah, blah. So she never vaccinated the child. And this young girl was very dehydrated. If she had kept this girl home for another 2 hours, the child would have died. That's how severely dehydrated she was. Lots of diarrhea she had. And when we did blood work on her, she had a very high lymphocyte count. Anybody remembers what lymphocytes are responsible for?
Creating antibodies.
Oh. What do lymphocytes do in the circulating blood, students? So when we do the blood work, you can see lymphocytes, you can see neutrophils. What do neutrophils fight off?
Antigens?
God, you're rusty. Neutrophils fight off bacterial infections, diseases caused by bacteria. So if you see a high neutrophil count, it means the person more likely has a bacterial infection. And if you see a high lymphocyte count, the person more likely has a viral infection. This young baby had a high lymphocyte count. So it was a clear indication that more than likely it was rotavirus, simply because the mother did not vaccinate this child against rotavirus. Right? A little story there that can be a little useful to you later on. Good. Moving on. Now, who do you think gastroenteritis might be a problem to? Who will die from gastroenteritis? Can you little children die from gastroenteritis? Are you likely to die from gastroenteritis? No, you're not. This is what we call self-limiting. The disease is self-limiting. What does that mean? Generally means it fixes itself. It fixes itself, right? With time, right? And while it fixes itself, the problem that will lead to death is if the person is not well hydrated. So hydration or dehydration can lead to death. Who are the two people who dehydration is usually likely to harm? Who do you think dehydration is likely to harm? Two sets of people.
Elderly and very young, or infants.
Very good, very good. Early and late. So the two opposite ends of the age spectrum. Because they are not able to get their fluid requirements as they might want to, right? They require somebody to give them that nourishment. That's a result why they often die from dehydration. Something else I want to tell you. Oh, but so what we can do an oral rehydrating solution, or when you go to the hospital might give you this in a packet. You can make it at home to prevent dehydration. You can make an oral.
Or is the IRS?
Yeah, oral rehydrating solution, and what this does, or what it is. So a glass of water, or half glass of water, 1 glass of water, 2 spoons of sugar, and 1 spoon salt. Sweeten that and drink it. So the salt and the sugar adding electrolytes to your body. The same electrolytes is what you're passing out. Right? So the ORS is very useful in preventing dehydration. That same thing I just told you about there. When you get diarrhea and vomiting, and you go to the hospital, they'll give you a little packet or they give you a little bottle and tell you drink. You can make it at home. Right? Good. Any questions? Any comments? Let's take a 5-minute break here. Anybody has any question? Are we learning?
Yes, sir.
Am I wasting my time?
No, sir.
No, sir.
Hopefully not. All right. So finish all those diseases. Let's talk about sickle cell. Sickle cell. So sickle cell, disease is really caused by evolution. So long ago, people of color were prone to get malaria, and lots of it, right? The body had to undergo, and that's what always happens. The body always go through some change, which will spontaneously cause mutations in the genes. And the mutation that occurred in the genes created sickle cell, right? So normally your red blood cells are looking like that, and your sickle cells will look something like this. When those cells give off oxygen and they are deoxygenated, they pick up a sickle shape. These are what your sickle cells look like. So this sickle cell disease is a genetic disease. You pass this from mother to offspring, from parents to offspring. So you want to make sure you test for this, because if one parent has a trait and the other person has another trait, you increase the likelihood of that child getting the disease. All right. These abnormally shaped cells, when they are shaped like this, that's dangerous. Can you tell me why?
Oxygen.
Hmm?
It does not carry as much oxygen.
No, that's not the problem. The problem is not that they're not carrying oxygen. There's another problem. Look at how it's shaped.
Sir, because the normal shape of a blood vessel allows it to pass through the fine blood vessels, and if it's sickled shape, it won't be able to pass through it.
Good. So it can cause blockage, right? And if it's a blockage, if there's a blockage in a blood vessel, what can that lead to? One person used that word necrosis earlier. And how can you tell me? Yeah, go ahead. So it leads to ischemia. So the tissue is without oxygen. And if that tissue continues being without oxygen after a while, that tissue will die. And when the cells die, that's what we call necrosis, right? Good. So, while we're on that, let me just tell you about this term apoptosis. Here they actually asked to define that term. So apoptosis is programmed cell death. Programmed cell death. Programmed cell death. So there are two types of cell death. One, apoptosis, and two, necrosis. Necrosis happens after oxygen doesn't go to the tissue. So after ischemia is necrosis. But the programmed cell death is if something is abnormal in this cell, the cell kills itself basically. And it says apoptosis. That usually happens when a virus invades a cell. Because the body can't get rid of the virus easily, it just kills the cell. Or if the cell is multiplying too rapidly, the body kills that cell because it's a cancerous cell, right? Oftentimes, the body does this easily, and then sometimes it doesn't do it as easily. And as a result, cancer occurs, right? Good. So going back to sickle cell, just trying to stick that in there because it's something that can come in the exam. So going back to sickle cell, so this disease occurs of the red blood cell, and when it occurs of the red blood cell, it leads to these blockages, right? These blockages can affect almost all over the body. In fact, all over the body. When I was a medical student, I had a patient, I think she was like 18 months, that had a stroke. Baby had a stroke. Do you expect a stroke in a baby? You expect a stroke in a young person? No. You expect stroke in big people, old people, right? But because these cells are abnormally shaped, they can clog up blood vessels. Stroke. If it happens in the brain, if it happens in the heart, it's a heart attack, right? But what are some common signs and symptoms of sickle cell disease? common signs and symptoms?
Joint pain.
Muscle weakness.
Pain, joint pain. That's the most common one. Joint pain. Why? Why do you think the joint is gonna pain or hurt? Why? Come on, think about what we just talked about here. What happens to these abnormal shape? Abnormal shaped cells are gonna block your blood vessels. So they're blocking these blood vessels at the point of the joints, and that will lead to pain, right? Pain because the tissue is being without oxygen. If that continues to happen, that tissue will die, right? So joint pain. What else? Paleness, fatigue, and this is coming because of the anemia, right? Remember, let's talk about anemia let's finish off by talking about anemia in a bit. Why is there anemia? Let's talk about that in just a bit. But yes, fatigue or weakness, we can have some shortness of breath, person panting for breath, shortness of breath. What else we can have? Jaundice.
Jaundice.
Jaundice. Very good. And that jaundice would lead to the anemia as well. All right? So not lead to the anemia, but jaundice is caused. Jaundice and the anemia is caused by the same thing. And we will talk about that in just a bit. Is there anything else that we can have in this sickle cell? Have you ever heard of the term priapism? Priapism. So in boys with sickle cell, usually in cold, not just in boys, but everybody, cold temperature causes a sickle cell crisis. Cold temperature causes a sickle cell crisis. Right? Remember that. That's something you just keep in the back of your head. So one of the things is that to keep the person warm. In a house, if a person has sickle cell, they should never have an AC in the house. Because every time the AC go on, they're gonna feel sick. All right, so yeah, but priapism is a condition where the young man early in the morning, everybody the young man would experience the morning hard on, that morning wood, as we refer to it as. In priapism, that penis remains hard for extended period of time. Why? Because the blood vessels that need to be drained of blood for you to get flaccid are blocked. And if that continuously happens, the tissue will be without oxygen and the tissue will die. The penis will die. So priapism is that extensive erection for more than a few hours. After 4 hours, the tissue starts to die. After 6 hours, it's terrible, right? So what they do, generally come to the hospital and we drain the penis, drain it of the blood. And this often happens almost always when there is a very cold morning, more than usual, right? So cold is an enemy of persons with sickle cell. Is there anybody here with sickle cell disease? It's not a curse. It's not anything to be ashamed of. It's very common. It's more common in Black people than anything else. And you know why? I told you earlier, evolution and malaria. Anybody here has sickle cell? Y'all ashamed to say it? That's why at least one person in school has sickle cell. Okay, y'all probably shy. But yeah, so let's talk about how we get this jaundice. What's jaundice? If somebody is jaundice, what's jaundice?
The yellowing of the skin.
Yellowing of the eyes or the sclera and the skin, right? So there's a yellowing of the skin. And why is there a yellowing of the skin?
Because of the increase in the bilirubin, sir.
Very good. Increased destruction of red blood cell lead to something called bilirubin release. When bilirubin is released, bilirubin has a yellowish color, so it causes that yellowing of the skin, right? And why is there anemia? What's anemia, students? What's anemia? What's
Sir,
anemia?
it's absence or lack of red blood cells.
A shortage of red blood cells, right? And the red blood cells are important for doing what?
Carrying oxygen.
Carry oxygen and carbon dioxide around the body, right? So if you have a shortage of red blood cell, that's why the person has all this shortness of breath, the feeling fatigue, and so on, right? Good. So in sickle cell disease, these abnormally shaped cells are bad. So what the body will do is increase the destruction of these cells. When the body increases the destruction of these abnormally shaped cells, this leads to destruction of the red blood cells and often lead to anemia and jaundice. Do you understand that? Or you want me to say that over? All right, so let's go to it again. I'm saying abnormally shaped cells, for example, in this case, the sickle-shaped cells, these abnormally shaped cells will be detected by the body. The body will remove them because the body knows it will be dangerous. So destroying these red blood cells lead to jaundice because bilirubin is leaked out, and it leads to anemia because of destruction of the red blood cells. Anybody know where these cells may be removed or where these cells may be destroyed?
In the liver?
Yes, in the liver and the spleen, right? The spleen is more common than the liver. Very good. Yes, let's move on. Someone's asking me to put on the comment section. Is the comment section not on? Yeah, the comment section is on. Not sure why you're asking me. All right, yeah, where are we? What's the next topic? Genetics. So let's do some genetics. So CXC's question on genetics will be quite easy. You know, my question on genetics is not often so easy. But let's try to do something simple. So let's say a black fur dog mates with a gray fur dog. What is the genotypic and phenotypic ratio of their offspring? Genotypic and phenotypic ratio. So we know to define these terms: homozygous, heterozygous, recessive, dominant, allele, genotype, and so on, right? Do you know to define those terms, or we have
Yes,
to go
sir.
through? If you don't know to define those terms, please check out my video on YouTube on genetic inheritance, right? Spend some time on genetic inheritance because it will be on the exam, right? So if somebody has a dominant characteristic, there are two possibilities they can have. Homozygous dominant, which is two big B's or two capital T's or two capital W. If there is heterozygous, they can also have that favorable characteristic. Why? Once you have one copy of a dominant allele, this is enough to cause a disease, right? Or cause the presence of a particular thing or feature, right? It may not always be about diseases. For example, in this case, we're talking about gray hair versus black hair fur, right? Good. So let's say this is a black hair fur. This is also a black hair fur. This case is saying that a black hair fur crosses with a gray hair fur. Gray hair dog. So this can be the crossing. Which one would it be? For you to know which one it would be, you have to give some more information. So let's say they say something like all the generation prior to the black hair dog came from all black hair. If they had a mixed picture, it would have been different. So all black hair would have been homozygous dominant. CXE wouldn't stress you out like that in HSB. They'll be simple. They will just give you this here and then give you this here, and you gotta put it in there, right? So let's say we're gonna use heterozygous. What define the term heterozygous for me, somebody?
When you have a dominant and recessive allele.
Having two different alleles for the same trait, right? Having two different alleles for the same trait, right? Good. What am I doing? So we have common B, capital B. What do we have? Capital B, common B. You always put a dominant allele first. Common B, common B, common B, common B, common B. What's the term for this?
Homozygous recessive.
Homozygous recessive, very good. Common B, common B. What's the term for this?
Heterozygous.
Heterozygous, good. So if you have to comment on the genotypic and the phenotypic ratio, what that simply means, for the genotype, you're going to comment on the genes. Genotype, the genes you're commenting on. So 2 of the 4 are heterozygous, so that's 50%. So 50% heterozygous, 50% homozygous recessive, or 2, 2. Can you see that? This is homozygous recessive, this is heterozygous. 50% heterozygous, 50% homozygous recessive. Is that clear?
Yes, sir.
It better be clear because the exam is tomorrow.
Yes, sir.
Phenotype now is the characteristics that we will see. We will not see the genes. We will not see heterozygous or homozygous recessive. We will see a color. So phenotype is when you're going to comment on the characteristic that is seen. So in this case, it will be 50% black hair and 50% gray hair. Make sense? Or 2, 2. You have to put a colon in the middle to show the ratio. Students, am I making sense or am I wasting my time?
You're making sense.
Making sense, sir.
That to be making sense because I'm not making sense. It's a pun. I hope I'm making sense because I'm not making sense.
You're making sense, don't worry.
I hope you would have told me I'm making both, but okay.
Oh, damn.
All right, so let's continue. Let me give you one quick work. Write too quickly sometimes. Let's try to write legibly. Sickle cell. Let's talk about sickle cell. So James has the sickle cell disease. And marries a woman Who is a carrier? Who has the trait? What is the chance or probability of them having children with sickle cell? Do your genetic crossing to figure that one out there for me. Give you a few minutes to do that. Have fun with it, and hopefully you do the right crossing. So because sickle cell disease is a disease or an abnormality of the hemoglobin, you usually put H to signify that, right? The H has no bearing on the cross, so you can ignore it. But the proper thing is to do is to put H. Right, so it's saying that one person had the trait and one person had the disease. So this is going to be the one with the trait. Doesn't matter if you put it at the top or the bottom, it shows the same thing. So let's say the AS there and the disease was there. What do we see? See that. If you put this, if you had gotten ES, SS, ES, and SS, that's correct as well. But understand what I'm saying at H, you put H to show that it's a characteristic or a disease of the hemoglobin, right? Is that what we got? We got something like that?
Yes, sir.
Good. And let's talk about the percentage
Yes,
now.
sir.
So 2 of the 4 will be diseased. So 50% chance of having the sickle cell disease and 50% chance of being a carrier of the trait. 50% chance of carrying the trait. Is that clear?
Yes, sir.
Good. Any questions or comments on that? No,
Sir, the age, do we have to put that in the exam?
I don't want to say yes, I don't want to say no. Just know you have to do it if they talk about sickle cell, right? The disease of the hemoglobin. People oftentimes ask these questions. Listen, do what you want. I'm not going to be responsible for you. Good. Next topic is what? Mitosis, meiosis. Let's compare mitosis and meiosis. What's mitosis? Mitosis and meiosis often describe cell division, right? So what is mitosis? What is meiosis? The difference between the two.
The mitosis creates two identical daughter cells, while meiosis creates 4 different daughter cells.
So mitosis is a cell division process that occurs in somatic cells or body cells. Mitosis occurs in the body cells. Meiosis occurs in the germ cells. So cell division occurs in the germ cells or the sex cells is meiosis, and mitosis is the cell division process that occurs in your body cells or your somatic cells. That's important for you to remember. All right. Yes, the other comparison is that mitosis produces identical daughter cells and meiosis produces unidentical daughter cells. Mitosis has a keeping of the 46 chromosomes or diploid number. Mitosis diploid number, meiosis haploid number. So meiosis has 23 chromosomes and mitosis will create 46 chromosomes. Is that clear so far?
Sir, say if you can't remember earlier, you could put 2N and N.
Yes, you can put 2N and N. Yes, that's fine as well. 2N and N. Good. Anything else? Any other questions there? Students always look for the easy way out, huh? Oh, God. Unfortunately, though, my battery is dying and I'm mobile, so I think we might have to cut this short. So let's talk about drugs quickly. Drugs. You should all know about drugs. Some of you do it. What's a drug?
Drug is a substance that hinders the body's normal functioning.
Anything that affects the body's normal function can be characterized as a drug, right? So drugs can be classified as a depressant to the nervous system or a stimulant to the nervous system. Depressants are those that slow down the nervous system. So everything that is supposed to be done by the body is done slowly, right? And the depressant and the stimulus will be speeding up the nervous system. So they do fast, right? So increased heart rate will be stimulant. Things like cocaine will increase the heart rate, while something like marijuana decrease the heart rate because marijuana is a depressant while cocaine is a stimulant. What are some psychological, not psych, what's a social problems with drug use? Social problems with drug use. The exam, HSB like to ask.
Divorce.
Increase in divorce because of increase in domestic problems, right? Difficulty in relationships, right?
So it can cause abuse.
Child
Because
abuse.
abuse, all kind of
Destroys family.
children, we're good. Y'all sound like y'all know this thing very well. I wonder why.
Yes,
Good.
sir. Yes.
And then there is the economic effects. So the economic effects of drug use, remember the money that you will use to spend to get drugs, the money spent on education and things like that. So drug use lead to some sort of poverty, right? money that should be spent on education or health or so on has to go on to be spent on rehabilitation and drug-seeking behavior, right? So those are some others there. Good. Give me a minute. Let me try to get some internet from another phone because my battery's gonna die. All right, good. Let's continue. What's the next step on our list? Can you hear me?
Yes.
Yes, sir.
All right, so I asked you to look at the list earlier for me. Anybody can look at the list and tell me the next topic we had to talk about. We spoke about drugs. What next is on that list?
Their foods.
All right, food, balanced diet, and so on. Good. So let's talk about food groups. What's a food group? Or what are the major food groups we have?
There's starch, food from animals, food from plants, fats and oils, protein.
No, protein is not a food group. Anybody else? So staples, food from animals, fats and oils.
Fruits and vegetables.
Fruits and vegetables. Good. And then those food groups now will give us nutrients, right? What nutrient will we get from staples or starchy foods?
Carbohydrate.
Yes.
Carbohydrate will be the nutrient, right? And these are all what we call macronutrients, right? Macronutrients. So carbohydrates, protein. Where are we getting protein from?
Food from animals.
Oh, we forgot another category. We forgot another group. Legumes, nuts, and seeds, right? Legumes, nuts, and seeds, especially for vegetarians, right? So legumes, nuts, and seeds also give us protein, right? Good. What else? What other nutrients we have?
Minerals.
Vitamins and minerals. Good. Let's talk about the function of these now. What's the function of carbohydrates? Carbohydrate provides energy, right?
Provides energy.
So they break down the glucose, which provides
Hello,
energy for.
Hello, hey. Be simple. Be simple. Nobody's talking about breaking or anything. You're asking the function of carbohydrates. All you say, carbohydrates function to provide energy. Stop trying to be complicated. Be simple on the exam. All right, good. Next, function of protein. What protein does?
Build and
Growth
repair
and repair,
species.
sir?
Build and repair cells. So it allows for the growing of new cells and the repairing of the cells that already exist, right? Good. What does fats do? What fats do?
Give energy.
They give energy as well, but they do something else.
Sir,
So
provide what?
they give 2 to 4 times more energy than carbohydrates. Remember that number? They give 2 to 4 more times energy than carbohydrates. But also they provide insulation. Yeah? Chubby guys are always winning. And you know why? They can be cuddled at night. The thin ones, they need some warmth themselves, right? So there you go. That's today's tip talk. Good. What else? What do vitamins and minerals do now?
Controls the body metabolism.
Very good. Metabolism. And what is metabolism really? Everything that the body does. Everything. That the body does, right? Good. What are your fat soluble vitamins? What are your fat soluble vitamins?
A, D, E, K.
D, E, and K.
Vitamins A. Yeah.
D, E, K. And your water soluble? B and C, right? B and C.
Right.
Remember that? What are some diseases we have now? When there's a shortage of vitamin E, what kind of disease you might think about vitamin E? So problems with the hair, problems with immunity, yeah? Problems with the skin, right? The hair, the skin, immunity. Vitamin K, very important for blood clotting or stopping bleeding, right? So vitamin K is very important in how blood clotting works. Vitamin B, not vitamin B, vitamin A. What is a disease you know that's caused by vitamin A deficiency?
Night blindness, sir?
Oh, night blindness, good. And C, vitamin C deficiency is caused by what? It's causing what? What disease do we have with
Scurvies.
vitamin C deficiency? Yes,
Scurvies.
scurvy. Good. Moving on. So your macronutrients would be your protein, carbohydrates. Your micronutrients would be your vitamins and minerals. So your body needs your macronutrients in a larger proportion. Your micronutrients are needed in small quantities. Though they are needed in small quantities, they are still very useful, right? Good. Any questions on that?
No, sir.
Good. What else on our list? What's the next topic on our list? Anybody has a list?
No, I came late.
Sir, thinking nothing else.
Oh, so germination, fertilization, pollination, photosynthesis, gestation, respiration. Let's talk about those things there. So, what is pollination?
Sir, is the movement of pollen grains from the anther of one flower to the stigma of another flower?
Or the same flower, it can be the same flower too, right? So it can be the pollination is the movement of pollen grains from the anther of one flower to another flower, or the pollen grains from the same flower to same anther of the same flower to the stigma of the same flower, right? So one more time. So the pollination is that process of moving pollen grains from the anther to the stigma. It can be of another flower, or it can be the same flower. So pollination is that. What is fertilization now? What's fertilization?
The fusion of two gametes, two sex
Very
gametes.
good. Very good. The fusion of two gametes. The fusion of the male and the female gamete. I'm happy you didn't say the fusion of a pollen grain and ovule or a sperm and an egg. Because the exam, if the exam tells you to define fertilization in plants, then you will tell me pollen and ovule. But if the exam says to define fertilization, you will simply say the fusion of a male and a female gamete. Is that clear?
Yes, sir.
Let's talk about fertilization in plants and fertilization in animals. We will do that. There can be a little description or a little essay type question tomorrow. So who wants to walk me through fertilization in plants? Let's do that. Anybody? All right, so I guess that's a point of need. All right, good. Let's talk about it. So fertilization, as we said, we just said what pollination was. So the pollen is moving from the anther to the stigma. So when the pollen gets on the stigma, the pollen goes down the style in the tubule, enters the ovary, and fuses with the ovule. Enters the ovary and fuses with the ovule. That is what we call fertilization plants. Simply that. So the pollen grain moves from one anther to the stigma. When it gets on the stigma, it gets sucked down the style in the tubule, enters the ovary, and fuses with the ovule. The fused ovule becomes the what? What does the fused ovule become?
Sir, the seed?
The seed, very good. And the entire ovary becomes what?
The fruit.
The fruit, very good. And let's talk about fertilization in animals now. You all know this one very well. Animals, also humans, right? Same thing. Let's talk about fertilization in animals. What happened there? Nobody? All right, so sperm is deposited in the vaginal tract. Sperm begin their ascent upwards, past the uterus, entering either of the fallopian tube In the fallopian tube, one sperm fertilize one ovum, right? Yeah, we got that. So vaginal tract ascending upwards, past the fallopian tube, past the uterus. Enter the fallopian tube. One egg will be somewhere either of the fallopian tube. When the egg is fertilized, we call that fertilization. Then that fertilized egg, also called a zygote, moves downwards into the direction of the uterus. That's another name for the uterus. That's another name for the uterus.
The womb?
The womb?
The womb or the womb? The womb, not the womb. W-O-M-B. Right, the womb. Right, so in the womb, implantation occurs. What's implantation? What's implantation?
The sinking of the zygote into the walls of the uterus.
The zygote embedding into the wall of the uterus or implanting itself into the wall of the uterus. Good. Sinking, okay, fair enough. Your words, good. Then what's gestation now? I can ask you for gestation. What's gestation? Anybody heard that word before?
No, sir.
So gestation is the time from fertilization to the time of delivery. So it's the entire period of that person being married. What am I saying? I'm hungry, forgive me. It's the entire period of the person being pregnant, right? I saw two persons walking on the street. So I'm thinking they were married, and so I say that. Anyway, yeah, what was I saying? Fertilization to the point where the birth is had. That whole process there is called the gestational period. Yeah, you got that? You understand what I'm saying, Shivan?
Yeah.
Yeah.
So from the point of fertilization to that point where the baby is put out of the uterus, expelled, is called gestation. Good. Anything else that I can bring here? Can't think of anything else. So what is the fertilization? What is pollination? I said that already. Let me see topics. Pollination. What's germination now? What's germination now?
Sir, germination is the
Sir, germination is the
process
where
of a
seed
plant.
becomes a seedling.
So it's a process where the seed goes into a seedling, right? Or the seed grows into a seedling. Good. So which one comes first? Of the processes, fertilization, pollination, germination, which one comes first?
Germination.
Nope.
Fertilization.
Nope. The pollination must happen. When the pollination happens, what happens next?
Fertilization, sir.
Fertilization. And when the egg is fertilized, when the egg, in this case the ovum, the ovule rather, when the ovule is fertilized, what comes next?
Germination.
Germination.
Germination, right? Unless if you can tie in photosynthesis and respiration. What comes next?
Sir, photosynthesis.
Photosynthesis and then respiration, right? Good. Let's talk about breathing and gaseous exchange now. Breathing and gaseous exchange. What's breathing? Breathing is the simple inhalation, exhalation of air. So you're taking in oxygen and giving off carbon dioxide, taking in air, giving off air. That's breathing. Gaseous exchange now is where you have an exchange of gases at the level of the bloodstream, trying to get oxygen into the blood and carbon dioxide from the blood out of the body. So gaseous exchange, exchange of gases at the level of the bloodstream. And breathing is just simply taking in air and giving off air. Making sense?
Yes.
Let's talk about
Yes, sir.
characteristics of good surface area. So the lung, the gill, the skin in some organisms, they form respiratory surfaces, right? What are the characteristics of respiratory surfaces? So something just came to my head. Learn to draw the structure of a villus. Learn to draw the structure of a villus. Do that on your own time for the exam tomorrow, right? So respiratory surfaces are large. Good respiratory surfaces are large. They have a large surface area. They have a large surface area. And they are often moist. They have a rich blood supply. And they're thin. Those are the 4 things I want you to remember. Large surface area, rich blood supply, thin, moist. Can we remember those? Good. You ought to remember those. Let's talk about veins, arteries, and capillaries. Veins, arteries, and capillaries, their structures and function. Veins, arteries, and capillaries, their structure and function. So how does, when you hear structure, what do you mean? When you hear structure, what do we mean?
Sir,
What?
Sir, how something is shaped.
Yeah, the shape, what it's made up of. Good. So that's structure. And let's talk about the function. What's the function of something? What's the function of something? What it does, right? So the structure is what it's shaped or what it looks like, and the function is what it does. Remember that. So let's talk about the structure of the vein. How is the vein structured?
Wide lumen.
Wide lumen. So thick, wide on the inside. So that's a space on the inside. Good. Thin walls, wide lumen, and it has a
Valve to prevent backflow.
yes, valve to prevent backflow. Good. Function now. What do veins do?
Sir, return blood to the heart because there is no muscle in the walls.
So veins return blood to the heart. Veins return blood to the heart. Because there's no muscle in the walls of the vein, that's the reason why it has a valve to prevent backflow, right? But don't get it twisted. Veins function to carry blood back to the heart. And most times, it is deoxygenated blood, blood rich in carbon dioxide. Okay? Let's talk about arteries now. What's about the walls of the artery?
Thick muscular walls.
It's thick.
Thick, sir.
What about the lumen on the
It's
inside?
Narrow.
Narrow?
And there are no valves.
No valves, good. Function now. What do arteries do?
Carry blood away from the heart.
Very good. Remember, A for artery, A for away. Artery carries blood. Arteries carry blood away from the heart. And usually it's what kind of blood?
Oxygenated blood.
Oxygenated blood. Good. And what about capillaries now?
So they're very small.
Very small, one cell at a time.
And the function, they link the veins.
They link veins to arteries, right? Very good. Very good. Next topic. Skeletal system. So let's talk about the function of the skeleton. What's the function of the skeletal system?
To protect the organs and systems in the body.
Protection, that's one. What else?
Support.
Making of red of blood cells.
Sorry to give the body
Posture.
Posture, shape. What else?
Movement.
Movement.
Movement. Anything else?
Sir, reproduction.
You just said production of blood cells. What else? How about storing of minerals? Storing minerals and also breathing, right? That's another one. Good. Let's talk about joints quickly. What's a joint?
So it's up where two bones meet.
Point where two bones meet. What are antagonistic muscles?
There are muscles that work in opposite each other.
Muscles that do opposite independent actions of each other. For example, the biceps and triceps. As the bicep contract, the tricep relax, right? Yeah? Okay, hope so. What's a ligament? What a ligament does? So we said a joint is where two bones meet. So the joint can be movable, all right? So the ligament stabilizes the joint, prevents too much movement of that joint, right? So the ligament stabilizes the joint. What do tendons do?
So connect muscles to bone.
Connect the muscles to the bone and allow for movement, right? So your tendons connect muscles to bone and allow for movement. Good. Next thing on our list is to talk about the stages of labor. So there are 3 stages of labor. Stage 1, 2, 3. Stage 1, so when we say labor, we're talking about giving birth, right? That's what the labor we're talking about. Not doing work, giving birth. So stage 1 is starting with contractions. And as the contractions happen, dilation also happens. Dilation is where the uterus, where the cervix opens up. So dilation is where the cervix opens up. And why you want the cervix to open up?
So to allow the baby to pass.
Yep, to allow the baby to pass through. So how big the cervix has to
Prepare
open up?
yourself for delivery.
How big does the cervix have to open?
10 centimeters.
10 centimeters, right? And usually the cervix is less than a centimeter, about a meter or so. So imagine you have to move from a meter to 10 centimeters. That's a very far away. So when the contractions start to happen, the cervix begin to open up, right? Good. Now, the second stage of labor is more contraction and then begin to push the baby out. Once the dilation happens, the baby begins to be pushed out, right? So the expulsion of the baby ends the second stage of labor. And the third stage of labor now is when you deliver the placenta, right? If the placenta is not delivered, if the placenta is left in the woman, she's going to bleed, and she's going to bleed to death, right? Have you heard of the hormone oxytocin?
Yes, sir.
Good. Oxytocin is responsible for contractions of that uterus wall, right? So the contractions that we were talking about is coming because of the hormone oxytocin. Is that clear?
Yes, sir.
So somebody was asking me to talk about the brain. Okay, let's talk about the brain quickly. So the brain, several parts. We're going to talk about three of them in particular. So there is the cerebellum, cerebrum, and the pituitary or the hypothalamus, right? So the cerebrum is where all the decision-making happen, the memory happen, the conscious thought, those stuff happen there. Senses, motor, and all of that happen in the cerebrum. The cerebellum, that was two L's, and let me write out that word here. Cerebrum, conscious thought, decision-making, interpreting senses, executive function like decision-making, movement, and so on happen here. And then the cerebellum, two L's in that. I want you to remember the L for balance. So the cerebellum is for balance and posture. Balance and posture, right? The pituitary and your hypothalamus play a role in production of hormones, right? The hormones are responsible for the endocrine functions of the body, right? So, do I need to zone in on anything there? Not really. No. Yeah, that's all I want you to know from the brain. Everything else should be application of that. Good. So that concludes my business with what I want.
Sorry to disturb you, sir, but could we go through the endocrine system, please?
Go look at the video. It's not gonna come. It's not gonna come. It's not gonna come. Trust my word on that. It's not gonna
Thank
come.
you, sir.
But you can go look at the video. Look at the video in case it comes. You're gonna say, "I ruined your life." Look at the video. Look at the video of the endocrine.
It's not going to come in the name of Jesus.
Yes, insert Jesus in everything y'all want to be against. In the name of Jesus.
Sir, pray for us tonight.
Yes, sir, please. We need it.
Bishop, y'all don't need prayers, man. Y'all done study already.
Who says, sir? You never know.
All right, let me pray. In the name of Jesus. Amen. All right, let's close our eyes, pray. Dear God, we come before your throne of mercy, your throne of grace, to thank you for yet another day. Lord, we bring these young people, these young adults to you. Thank you for the journey that they have walked on the last year, last 5 years in preparation for this exam. Lord, you know some of these young people need to pass this for their career choice. Some of them have tried before, kind of failed. We bring them to you because this time is going to be different. You said in your word, your people shall be the head and not the tail. They shall be above and not beneath. They shall be victors and never victims. Lord, we're holding upon your word. The same word and the same favor that you've given Joseph, the same favor you have given Isaac, the same favor you have given Job. We're holding upon your word. You said, ask and it shall be given, knock and the door shall be open, seek and we shall find. Today we are doing all of those things. For they have prepared themselves, they have worked, they have attended classes, and they have done their bit. All they have to do now is to write this exam and pass. Or we pray against the spirit of nervousness. We pray against the feeling of not good enough. We pray against the feeling of failure, oh God. For they have worked assiduously and their result should be a pass. Their result should be a grade 1. Their result should be at least a grade 2, oh God. We give you the glory, the honor, and the praise because you alone deserve it. Lord, we thank you for the persons who are going to this exam and they don't know what they're going to do, but they're having faith, oh God. Faith that they are going to pass. Faith that the 2 topics they've studied is right on the exam paper, oh God. We thank you for your mercies. We thank you for your grace because we know that you are capable of doing all that they did not do. We give you the glory, we give you the honor, we give you the praise. In no other name but the name of Jesus Christ. Amen.
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 Crossfield come to the class in time to say amen.
Wow. The first and third.
All right, have a good one. Take care of yourselves. Get some early rest. And the persons who are doing chemistry tomorrow, may Jesus be with you all.
Pressure.
Yeah,
Sir, there's the real reason I need to pray, to be honest, not for HSB, for chem.
Listen, I'll tell you what. I have a quick story with you. When I was writing CXC many moons ago, I woke up early and decided not to go to my chemistry exam. And then I changed my mind. Then I said, you know what, I'm going. My mother didn't raise no punk. And I went to the exam, and then when I went to the exam, I regretted going to the exam, because the exam be hard. But while I was in the exam, I struggled through. I tried and answer everything. I even sleep in the exam. Invigilator came and asked me, Invigilator was like, son, what happened to you today? You should be busy writing away. I said, the exam hard. She was like, all right, man, just try and do something. So your body was motivated to do something else. Long story short, I passed with a grade 2. Even though it was horrible, I don't know how I got that 2, but I got a 2. And if I didn't go to that exam, I wouldn't have been a medical doctor today. So I'm telling you right now, you might see it as impossible. You might see it as though you can't do it, but there's a blessing in showing up. So don't be distracted. Don't feel frustrated. Just show up. God shall do the rest. All right? Show up and let God do the rest. You are going to be fine. Don't worry. Just show up and do something. Write something on that exam paper and you will be all right. All right?
Thank you very much.
You are most welcome.
Good.
Bye, sir.
Bye-bye.
Thank you, sir. Later. Good night.
Bye.
Bye, sir.